Recording.
Okay, are we good? So we're gonna have a talk about the force on a charged particle moving through a magnetic field. So in our brains we have to separate off. There's two different things that are both fields. One's magnetic and one's electric, and they're completely different. We have to not get confused and read the word field and just be like, oh, it's field. No, it's different. Magnetic field, electric field. And so to get into the magnetic field space, we're going to have to make some new arrows, some arrows that work in three dimensions. We've got arrows that work going to the right, going to the left, going up, going down. We need arrows that work going out and going in. And so this is like when a game of darts goes really well, and you throw the dart and you see the dart flying away from you, and when the game of darts goes really, really badly and someone throws the dart at you, you see the point of the dart coming towards you. And so this symbol here is in to the page or to the board or to whatever you're writing on, so that shows something moving that direction, and this one's out of the page, so that shows us something going that way. And so making sense of that over here, all of those X's show us a region of magnetic field that's going into the board. And so what we've got is a positively charged particle moving along with speed v, and what we're interested in is what does it do as it enters the magnetic field. The rule that we can use to work out what happens to it is called the right hand slap rule. So we have to do this with our right hand for this to work, and the thumb is going to show us the direction that the particle is moving, that way. Your fingers are going to show you the direction of the field into the board, and the slap shows you the direction of the force on a positive charge. And so at that instant, when it enters the field, the force is going to be upwards. But hang on, if that force pushes the charge upwards, that charge is going to turn, it's going to move a little bit upwards. And so that's going to go like that. And so then we reassess. It's going that way, fingers are field. Oh, now the force is that way. And so it curves a little. What?
You just turn all the way around.
And so what we notice about the force that was acting on that particle as it moved through the field is that that force wasn't always pointing in the same direction. The direction that force was pointing changed as the particle moved through the magnetic field. It was always pointing at right angles to the particle's motion. A force that always points at right angles to the particle's motion. So does it ring a bell? Circular path, centripetal force, and so in this case, the force due to the magnetic force on the charged particle has acted as a centripetal force, and it's made our particle move in a circular path. If it were a negative particle, then the force would be in the opposite direction, because it's negative charge. And we've got an equation for this force. The force depends on the magnetic field strength, the size of the charge, and how fast that charge is moving. And we just need to add that the magnetic force provides a centripetal force.
Oh, right. Yeah, I got that.
Todd fails at a bottle flip once.